Okay, recall guys, your NI here is just NP, total number of moles, times the mole fraction of the component I. Okay? Okay. Next, number 49. Davies equation is the most appropriate equation to use to determine the activity coefficient when okay, A, the activity is greater than 1, B, the activity is less than 0.1, C, ionic strength greater than 0.1, D, ionic strength is less than 0.01. So guys, in order to determine the activity coefficient, we have to use the Debye-Huckel limiting law, extend the Debye-Huckel law, and the Davies equation. So guys, kung sino man ang gagamitin natin dyan, it depends on the ionic strength. So recall this table, guys. Diba? If ionic strength is greater than 0.1, then the best equation to use is the Davies equation. That's why for number 49, the answer is letter C. Okay? Very easy, guys, right? Kaya. Okay. Next, number 50. What is the boiling point of a 3.5% aqueous NaCl solution? So guys, these are your choices. Ano kayang sagot nyo? Okay, recall guys that for NaCl, this is an electrolyte solution. Tama? Again, you have an electrolyte solution. Guys, ito yung tandaan nyo. Kapag may electrolyte solution kayo, okay, di ba mag-dissociate yan in solution? Guys, okay, this results in a non-ideal solution. Ma'am, bakit? Because guys, your interactions between Na and Cl are electrostatic interactions. And guys, electrostatic interactions, okay, will arise in non-ideal solutions. Okay? Ma'am, bakit? Kasi guys, yung interactions na yan are significant, okay? Which will affect the interactions of individual molecules or the interactions between unlike molecules, okay? So recall, this is the dissociation of NaCl in water. Ma'am, bakit water agad? Guys, you have an aqueous NaCl solution. Again, guys, kasi having aqueous NaCl in water. So we have formed here Na plus Cl minus. So unang gagawin natin guys is to determine the Van Hoff factor I before we determine the boiling point. So to get the Van Hoff factor I, alpha, the degree of dissociation is equal to I minus 1 over V minus 1, where V is the number of ionic species. So substitute lang guys. We know that NaCl will fully dissociate in water, right? So its degree of dissociation is 1. 1 is equal to I minus 1 over 2 minus 1, where V is equal to 2 because you have 2 ions, Na plus and Cl minus. Solving guys, I is equal to 2. Okay, now we are ready to determine the boiling point. So, paano natin kukunin ang boiling point? Through the boiling point elevation equation. Okay, so before we do that, guys, determine or simplify muna natin ang ating molality equation. Okay? Okay, how do we get the molality equation? It is using this concentration here. Sabi dito, we have 3.5% aqueous solution. So, guys, gawin natin yan. 3.5 grams NaCl, that is just equal to 3.5 grams NaCl over 100 grams solution. Diba, guys? Again, 3.5% aqueous NaCl solution is just equal to 3.5 grams NaCl over 100 grams solution. Now, guys, recall, for molality, our unit is mole solute over kilogram solvent. Tama? So, ito, so guys, dapat yun nasa denominator nga in terms of kilogram solvent. Kaso nga lang, ang meron sa denominator natin ay 100 gram solution. So, how do we determine the kilogram solvent? So guys, 100 gram solution minus 3.5 grams NaCl, which is your solute. So again, gram solution minus gram solute, which is NaCl, is just equal to the grams of the solvent. Okay? So 100 minus 3.5, you get 96.5 grams of water, your solvent. Tapos convert the grams of water to kilograms of water, okay? Where 1 kilogram is equal to 1,000 grams. Okay? So again, this is your expression for molality. Isa-substitute natin yan later. Okay? Okay, so of course guys, tandaan, syempre guys, hindi pa tayo tapos dito, diba? So ang gagawin, si 3.5 grams, convert pa natin to moles. Okay? So let's do that later, guys. Ayan. So again, to get the boiling point, we use this equation here. Delta TB is equal to IKBM, where delta TB is equal to TB minus TB naught. Okay, recall guys, yung boiling point ng solution nyo will always be higher than the boiling point of the pure solvent, which in this case is water. Again, bakit guys? Because the solute, okay, hinders the boiling of your particles. That's why your solution would require a higher boiling point in order for the liquid to vaporize. Okay, so delta TB is equal to TB minus TB naught is equal to IKBM. Okay. Ma'am, ano si KB? So guys, again, you have an aqueous NaCl solution, so you know that your solvent is water. So yung gagamitin nyo na KBI, 0.512 degrees Celsius over molal. Okay, so let's substitute. Okay, TB is equal to IKBM. Again, this whole expression here is IKBM. I is 2 times Kb, 0.512 degrees Celsius over molal, times your molality here. So again, 3.5 grams, convert grams to moles, where mass divided by molar mass lang ang gagawin natin, di ba? NaCl, the molar mass of NaCl is 58.4 grams over mole, di ba? Divided by kilogram solvent, that is 0.0965 kilograms of water, your solvent, plus 100 degrees Celsius, the boiling point of pure water. Solving, guys, you will get 100.64 degrees Celsius, letter C. I hope that's clear, guys. Ayan. Next, number 51. What is the process of determining the lowered freezing point of a liquid with dissolved solute to further determine its molecular mass? Oh, guys, ano kaya yan? So that is letter C, cryoscopy. So based on this table, guys, okay, in order to determine the lowered freezing point of a liquid with dissolved solute to further determine its molecular mass, okay, gagamitin natin ay ang cryoscopy. Okay? Guys, kung hindi nyo alam yung meaning lahat na ito, tingnan nyo lang keyword, okay? Freezing point. Tapos, kailangan natin ma-determine ang molecular mass. Oh, tingnan ang table, di ba? For molecular mass determination, cryoscopy is important. Therefore, letter C is the answer. Meanwhile, guys, for molar mass determination for osmotic pressure, osmometry is involved. Pero pag for molar mass determination naman sa boiling point elevation, ebullioscopy is involved. Okay? Ayan, so next guys, ayan. Next topic na agad. Punta tayo sa ating phase equilibria questions. So we have here 9 questions on phase equilibria. So let's see, guys. So number 52, hexane octane mixture has a degree of freedom of 1, 2, 3, or 4. So guys, all you have to do is determine the formula for the degrees of freedom first, diba? Okay, so una sa lahat guys, you have 2 components, hexane and octane in your mixture. And for your phase, you only have 1. Bakit? Because you have a completely miscible liquids. Again, you have 2 completely miscible liquids, hexane and octane, diba? Okay, so F is equal to C minus C plus 2. Okay, so 2, which is the components, minus 1, the phase, plus 2. You get F is equal to 3. So the answer is letter C. Diba? Very easy guys. On next, number 53, the Clausius-Clapeyron equation applies to phase transitions between, ayan guys, ano kaya sagot ko dito? So recall guys, this is the Clausius-Clapeyron equation, which relates the vapor pressure of a gas, okay, to its temperature. Okay, again, this is the 2.4 of your Clausius-Clapeyron equation. This is the linearized form, Ln P is equal to negative delta H over R times 1 over T. Now, the derivation and usage of the Clausius-Clapeyron equation assumes one phase is a gas. Again, we assume that one phase is a gas. Bakit? Kasi guys, kinukuha natin yung vapor pressure, diba? And the other phase guys is a condensed phase. So that is either a liquid or solid. Okay? Again, the condensed phase is either a liquid or solid. Okay? In that case guys, diba? For example, yung solid pwede siyang mag-sublimate, diba? To form vapor, diba? And if that forms a vapor above the solid, then you have vapor pressure. And then of course, for your liquid, diba? If your liquid vaporizes to form vapor molecules, diba? You have vapor pressure above the liquid. So guys, answer for number 53 is letter D, gas phase and any condensed phase. Claro? Pag sinabi natin condensed phase, guys, okay, meaning the Clausius-Clapeyron equation can only apply in solid gas equilibria and liquid gas equilibria. Okay? So for solid liquid equilibrium, guys, you cannot apply the Clausius-Clapeyron equation. Okay. Next, number 54. At the triple point of water, which phase has the lowest entropy? So guys, this is the triple point of water, right? So among ice, water, and water vapor, sino kaya may lowest entropy? Guys, syempre, si letter A, solid. Okay? Guys, kahit sa triple point tayo, anong meaning ng triple point? Meaning, all three phases coexist at equilibrium. Tama? Oh guys, solid still has the lowest entropy in this case. Diba? Okay, hindi equal ang entropy. Ano kaya equal sa kanila, guys? Again, at the triple point, the chemical potentials of ice, water, and water vapor are equal, not the entropy. Okay. Next, for number 55, liquids A with vapor pressure 650 torr and B are both volatile. Okay, so the mole fractions of B in the liquid phase is 0.45 and 0.78 in the vapor. What is the vapor pressure of the solution? Okay, guys, so you are given here two volatile liquids. Okay, so we will apply the Dalton's law and the Raoult's law. Again, if you have two volatile liquids, apply Dalton's law and Raoult's law. Okay. So guys, meron tayong correction dito. Okay, nagtataka kayo bakit kayo nagkamali dito or bakit iba yung sagot nyo. Okay guys, so now number 55 is a bonus question. Okay, again guys, bonus question na ang number 55 because the correct given guys dapat is the mole fractions of A in the liquid phase is 0.45 and 0.78 in the vapor. Again guys, ang correct na problem na question dito ay dapat the mole fractions of A in the liquid phase is 0.45 and 0.78. Okay, so from here guys, makakakuha na kayo ng sagot from the choices. Okay, again guys, this is now a bonus question. So take note guys, bakit siya naging bonus kasi dapat the mole fractions of A in the liquid phase dito. Okay, guys. Okay, so solving. Okay, again we use Dalton's and Raoult's law since we have two volatile liquids. Okay, bakit tayo may two volatile liquids? Okay, sabi dito both volatile, diba? So guys, YA here is 0.78, diba? This is the mole fraction of A in the vapor phase, and XA is the mole fraction of A in the liquid phase. So again, we use Dalton's and Raoult's law, okay, in order to relate these mole fractions and in order for us to get the vapor pressure of the solutions. So recall guys that from the Raoult's law, the vapor pressure of A in the solution is equal to the mole fraction of A in the liquid phase times the vapor pressure of pure A, which is equal to the mole fraction of A in the vapor phase times the total pressure. O ma'am, saan to galing? Again, from the Dalton's law, where the mole fraction of A in the vapor phase is equal to the partial pressure of A divided by the total pressure, diba? Okay, kaya PA is equal to YA times PT. So guys, substitute lang natin. Ayan, so we know guys that XA is equal to 0.45, P naught A is equal to 650, YA is equal to 0.78, and PT is yung total pressure ng solution nyo, vapor pressure of your solution, which is yung hinahanap natin. So simply shift solve guys, and you will get 375 torr. Again guys, paano ma'am kung mole fractions of B talaga to? Ang makukuha yung sagot guys ay 16254 torr, tama ba? Ayan guys, so again, this is a typo. It should be mole fractions of A, not mole fractions of B. Okay, again guys, bonus question ang number 55. Okay, again, the correct answer for number 55 is letter A, because we are given here mole fractions of A, XA, and YA. Okay, try you solve on your own guys. Okay. Next, number 56. It is used to determine the relative amounts of the phases in equilibrium. Oh, so these are the choices, guys. So obviously, that is inverse Lever-Arm rule. Recall, guys, this is the inverse Lever-Arm rule. Okay, the moles of liquid divided by the moles of the vapor is equal to segment V over segment L. Inverse, diba? And alternatively, guys, from this equation, we can also determine the fraction of vapor and the fraction of liquid. So ang fraction of vapor, guys, is segment L. Ito yung segment L nyo. Divided by segment L plus V. Tapos ang fraction of liquid naman, so that is segment V divided by L plus V. Ma'am, bakit L plus V? Guys, we are looking for the fraction of vapor and fraction of liquid in the whole mixture. Okay, again, for number 56, answer is letter B. So for number 57, which of these is true given the phase diagram of sulfur? Okay, so these are the choices, guys, and this is your phase diagram. So this is a previous board exam question. Okay, again, this is a previous board exam question, number 57. So tingnan natin isa-isa, guys, ang ating choices, diba? So all you have to do, guys, is to analyze your problem. Okay, so sabi sa letter A, monoclinic sulfur sublimes at 1 atmosphere, while rhombic sulfur does not. Okay, so dito si rhombic sulfur, diba? Dito si monoclinic. So si monoclinic sulfur, guys, sabi daw, it's sublime. So from solid to gas at 1 atmosphere. Saan si 1 atmosphere? Nandito, guys. Okay. Tingnan nyo, ano nangyayari at 1 atmosphere? Sublimation ba? Okay, syempre hindi, di ba? Therefore, letter A is false. Next, letter B. Sabi dito, rhombic sulfur is less dense than monoclinic sulfur. So this is rhombic, this is monoclinic. Guys, ganito yan. Kapag less dense ang rhombic sulfur compared to monoclinic sulfur, then dapat negative ang slope between them. But guys, you have a positive slope between rhombic sulfur and monoclinic sulfur, di ba? So if you have a positive slope, guys, meaning rhombic sulfur is actually denser than monoclinic sulfur. That's why letter B is wrong. Next, letter C. At temperatures above 119 degrees Celsius, okay, monoclinic sulfur cannot exist at equilibrium. So punta tayo, guys, 119 degrees Celsius, above 119 degrees Celsius. Ito yun, di ba? Sabi, monosulfur cannot exist at equilibrium. Is this true? Any guess, guys? Is this true? Actually, guys, this is false. Tingnan nyo this, guys. Dito. This is already temperature above 119, tama? Okay, at this point, at this certain pressure here, and at a temperature above 119, just here, guys, monoclinic sulfur can still exist. Okay, so letter C is wrong. Now, what about letter D? The conversion of rhombic to monoclinic sulfur is endothermic. So, from rhombic to monoclinic, sabi endothermic. Actually, guys, this is true. Bakit? Because your rhombic sulfur, diba, it exists at lower temperatures, diba? Nandito siya, lower ang temperature. Si monoclinic sulfur naman, guys, exists at higher temperatures. So, converting your rhombic sulfur to monoclinic sulfur, okay, requires an absorption of energy, okay, in order to increase the temperature, diba? That's why the conversion of rhombic to monoclinic sulfur is endothermic. So, the answer is letter D, okay? I hope it's clear, guys. Next, number 58. A section of the phase diagram of uranium hexafluoride UF6 is shown. Which of the following statements are correct? 1. Statement 1, UF6 sublimes rather than melts at 1 atmosphere. 2. At 2 atmosphere and 45 degrees Celsius, only solid UF6 is present at equilibrium. Okay. So, guys, tingnan mo na statement 1. UF6 sublimes rather than melts at 1 atmosphere. This is 1 atmosphere. So guys, this is true, diba? Look, you have a sublimation from solid to vapor, ba, at 1 atmosphere. Okay? So this is correct. Next, guys, tingnan naman natin si statement 2 at 2 atmosphere and 45 degrees Celsius. So around dito. Okay? Only solid UF6 is present in equilibrium, and this is correct. Therefore, the answer for number 8 is letter C. Yes, guys? Okay. Okay, number 59. Hindi tayo binigyan ng graph, guys, sa ating EVAL exam. Pero familiar ang question, tama ba? Siyempre, tama guys, di ba? Okay. So guys, gagamitin natin yung phase diagram galing sa PD, okay? So it is desired to increase the concentration of cyclohexane in a cyclohexane toluene solution that contains 20% cyclohexane by stage-wise distillation. At what temperature will the first distillate oil? So guys, again, the answer here is 92 degrees Celsius. Okay, recall natin. Okay, if you have 20% cyclohexane, meaning guys, you have 80% toluene. So your 80% toluene, 25% cyclohexane mixture will boil at this certain temperature here. Ma'am, bakit higher? Because konti lang ang cyclohexane mo. Cyclohexane guys has a lower boiling point compared to toluene, tama? Since cyclohexane has a lower boiling point than toluene, and mas marami ang toluene mo than cyclohexane, then you would expect a higher boiling point. Okay? So the boiling point guys of this mixture is somewhere in between the boiling point of cyclohexane and toluene. Okay, so magbo-boil na guys at this point ang inyong mixture. Okay, so from liquid to vapor. Yan guys, liquid to vapor. Now, yung vapor na ito is now richer in cyclohexane. Again, bakit richer ang vapor na ito in cyclohexane? Because guys, syempre mauunang mag-vaporize ay si cyclohexane because it has a lower boiling point. Okay? Ma'am, ano yung clue? Bakit ma'am si cyclohexane ang may lower boiling point? Okay, so recall your IMFAs. Okay? So sino ang may weaker IMFA? Cyclohexane or toluene? Yes, syempre si cyclohexane, di ba? So since it has a weaker IMFAs, therefore it has a lower boiling point. Since your vapor is mostly cyclohexane, therefore your vapor is richer in cyclohexane. Now, let's condense your vapor here. Kukunin natin ang ating first distillate. Klaro ba guys? Again, kukunin natin ang ating first distillate in this case. Okay? Now, let's collect your first distillate. Andito na siya guys. Diba? This is your first distillate. Okay? Now, your first distillate is now richer in cyclohexane. Now guys, let's say, purify pa natin further ang ating first distillate. Diba? So, diba, yung first distillate, siyempre, nung kinondense mo yan, nag-cool yan, diba? So, paano natin kukunin ang first distillate guys? Siyempre, i-vaporize muna natin yan, diba? Vaporize at this boiling point here. Again, this is the boiling point of your first distillate. So, what is the boiling point of your first distillate? Ito guys, 92 degrees Celsius. Letter B. Okay? Next, number 60. At a certain temperature, the vapor pressure of water is 23.76 torr. What is the vapor pressure of solution of sucrose has a mole fraction of 0.250 in the solution. So, these are the choices, guys. Ayan. Okay. So, recall guys, this is your Raoult's law. Okay? The vapor pressure of the solution is just equal to the mole fraction of the solvent times the vapor pressure of your pure solvent. So, guys, the vapor pressure of the pure solvent, water, is just 23.76 torr. Tama? Okay. Again, this is your peanut solvent, 23.76 torr. Okay? Okay. Tapos, ang mole fraction ng inyong solute, guys, is 0.250. So, if the mole fraction of your sucrose, which is your solute, is 0.250, what is the mole fraction of your solvent? So, guys, your solvent's mole fraction is 1 minus 0.250, which is equal to 0.750. Okay? And so now we can solve for the vapor pressure of the solution. Vapor pressure of the solution is equal to 0.75 times 23.76 torr. Solving, guys, we get 17.82 torr. Letter D. Okay? Ayan, so we are done with our phase equilibria questions. Now let's answer our electrochemical equilibria questions. So we have 5 items for this one. Ayan. So for number 61, which response contains all of the following statements that are correct and no others? Okay, so we have here 1, in voltaic cells, the flow of electrons is spontaneous. 2, in electrolytic cells, electrons flow in the external circuits through the wire from the anode to the cathode. 3, in voltaic cells, the cathode is the positive electrode. Oh guys, ang answer ay si letter C. 1, 2, and 3 are correct. Okay, so let's go into them guys. Statement 1 is correct. In voltaic cells, the flow of electrons is spontaneous. That is correct, diba? Because the voltaic or the galvanic cells operate via spontaneous redox reactions, right? Right guys? Okay, next statement 2 naman. In electrolytic cells, the electrons flow in the external circuit through the wire from the anode to the cathode. Guys, statement 2 is correct. Okay, so guys, even though the electrolytic cells reaction is non-spontaneous and it requires an external power source, guys, the electrons will still flow from anode to cathode in the external circuit. Okay, just like in voltaic cells. Okay, statement 3, in voltaic cells, the cathode is the positive electrode. So this is true, diba? Anode, guys, is a site of oxidation. Tama? Again, anode, site of oxidation. Okay, it is negative. Cathode naman, site of reduction. Right? So this is positive. So again, for number 61, the answer is letter C. O, tingnan dito guys, ang figure natin, electrolytic cell, ang flow ng electrons ay from anode to cathode. Again guys, okay, kindly correct this one. Again, ang flow ng electrons is from anode to cathode, okay, for electrolytic cells. Except guys, kailangan nyo na mag-apply ng power source. And with that, kindly correct page P53 guys, okay? So, correct table 36, electron flow for electrolytic cell. So, dapat ang electron flow for an electrolytic cell is from anode to cathode. And this is forced by a power source, okay? Again, correct on page P53. Okay? Next, number 62. Okay. Previous board exam question. When a current is passed through a cell with silver nitrate, 1.44 grams of silver is produced. Using the same circuit, how many grams of copper will be deposited from cupric sulfate? Okay, guys. So, ang ating equation ay based on the second law of Faraday's second law of electrolysis. So, the mass of Ag divided by the equivalent weight of Ag is equal to the mass of copper divided by the equivalent weight of copper. So, guys, we are given the mass of the silver, 1.44. Hinahanap natin mass ng copper. Okay? Tapos, ang equivalent weight ng inyong silver ay 107.9 divided by N, which is 1, di ba? Okay, guys, for Ag, it involves the transfer of 1 electron. Tama? Tama? Okay. For copper naman, it involves the transfer of 2 electrons. That's why the equivalent weight is 63.5. 63.5 is the molecular weight of copper divided by 2. So, shift solve lang guys and you will get the mass of copper is equal to 0.42 grams. Letter A for number 62. Okay? Next, number 63. A current of 1.20 amperes passed through a solution of metal nitrate for 153 minutes plates out 3.92 grams of the metal. What is the metal? So, guys, ang gagawin natin is trial and error. Okay? Trial and error. Tapos, kung makukuha natin ang 3.92 grams, okay, from the formula of the Faraday's first law of electrolysis, okay, edi yun yung sagot. Okay? Again, these are your choices, guys. Hahanapin natin isa-isa ang kanilang mass deposited or mass plated out. For nickel, guys, the mass deposited is equal to the molar mass of nickel, 58.69, times the current, 1.20 amperes, times 153 minutes, convert to seconds. Seconds, guys, is the SI unit of time, 9180 seconds. Again, to get 9180 seconds, ano lang yan, 153 times 60, divided by 2. So, guys, N is equal to 2 for nickel 2 plus packet. The transfer, for nickel 2 plus, guys, that involves the transfer of 2 electrons. Nickel 2 plus, okay? 2 times F, and that is equal to 3.35 grams, okay? Okay. Next, guys, for letter B, copper. And mass is equal to molar mass of copper times 8 times I times T divided by 2 over 2 times F. F here is the Faraday's constant. Or recall guys, your Faraday's constant is equal to shift convert 16. Tama? Okay. So solving we will get 3.62 grams. So balik. Dapat guys, makuha natin 3.92 grams. Okay? Next, punta natin si RH. Okay? RH mass is equal to 102.91 grams per mole. So hanapin nyo lang sa periodic table ang kanyang molar mass times 1.2 times 9,180 seconds divided by 3. So guys, RH, okay, involves the transfer of 3 electrons. Okay? RH 3 plus ang kanyang charge. Okay? 3 times F, solving we get 3.92 grams. Actually, ito yung sagot. Next, letter B. Barium mass is equal to 137.33. This is the molar mass of barium. Barium times 1.2 times 9,180 seconds divided by 2 times F. So for barium, guys, it involves the transfer of 2 electrons. Diba? It forms barium 2 plus. That's why the answer here is 7.84. Malayo sa 3.92. Therefore, the answer for number 63 is letter C, RH. Okay? Next, number 64. The Kohl-Rausch's square root law applies to A, metals, B, strong electrolytes, C, weak electrolytes, and D, gases. Oh, guys, recall from table 40, diba? Okay, ano kayang sagot? Siyempre, letter B, strong electrolytes. What if meron tayong weak electrolytes? So, gagamitin natin ang Oswald dilution law. Okay, guys, review again. Okay, pag gagamitin ang Kohl-Rausch square root law, tapos binigyan tayo ng set of concentration and molar conductivity values, this is your X, diba? Square root of C. Tapos your Y is molar conductivity. Now, what if you have to use the Oswald dilution law? So, your Y is 1 over molar conductivity, and your X is concentration times molar conductivity. Again, your X for Oswald dilution law is concentration times molar conductivity. Okay? Next, number 65. Within the which ACl solution has the highest conductance? So, this is a previous board exam question. Ayan. So guys, take note, iba ang conductance sa molar conductivity. And guys, iba ang trends nila with the concentration. Okay, so makinig. This is a previous board exam question again. Okay, so conductance, guys, it is the ability of a solution to conduct electricity. Again, this is different with molar conductivity. Okay, guys, pag sinabi natin molar conductivity, it is the conductivity per mole of solute, di ba? Okay, again, iba silang dalawa. So iba din sila ng trend in terms of the concentration. Guys, we know that HCl is a strong electrolyte and it dissociates completely to form H plus and Cl minus ions, right? So, guys, this is a trend. As concentration increases, the conductance increases. Directly proportional silang dalawa because, guys, if you have a greater concentration of your electrolyte, then you have more ions that will carry the current. Okay? Again, conductance and concentration directly proportional. Molar conductivity and concentration inversely proportional. Ma'am, bakit inversely proportional for molar conductivity? Okay, guys, recall molar conductivity is the conductivity per mole of solute, di ba? Okay, so ma'am, bakit nagde-decrease ang molar conductivity with concentration? Because guys, at high concentrations, okay, yung ions nyo are now crowded, okay, and they will interact more, okay, which reduces their mobility due to ion pairing or electrostatic interactions between the ions, okay? That's why the molar conductivity decreases as you increase the concentration. Okay, again guys, iba ang definition ng conductance and conductivity. That's why the answer for number 65 is letter B, 0.1 molar HCl. Tandaan ha, iba ang trend ng conductance sa molar conductivity, okay? Ayan, so basically guys, pag conductance G, okay, as you increase the concentration, increases ang conductance, okay? More ions means more charge carriers. Yun ang definition. Habang for molar conductivity naman, okay, if you increase the concentration, molar conductivity decreases because there is an increase in the ion-ion interactions which reduces the mobility of your ions. Again, letter B ang tamang sagot. Next, chemical kinetics na questions. So we have here 6 questions on chemical kinetics, guys. Number 66, for a gaseous system in a closed container, which condition will increase the reaction rate? So these are the choices, guys. A, heat the container. B, introduce a catalyst poison. C, increasing the volume of the container. Or D, lowering the number of gaseous particles. So guys, okay, tingnan natin ibang choices. Mamaya na si letter A, okay? For B, guys, it is false. Bakit? Because the catalyst poison is like an opposite of the catalyst, tama? Because it slows down or inhibits the action of your catalyst. Okay, again, it slows the reaction. Letter C naman, okay, increasing the volume of the container decreases the pressure, right? Huh? And if you decrease the pressure of the container, which contains your gases, guys, decrease mo yung concentration of the gas molecules of the system. Pero guys, ayan. So if you have a decrease in the concentration of the gas molecules in your system, okay, syempre, mas konti na lang yung gas molecules na magko-collide with one another. If you have fewer collisions of the gas molecules, you have a slower reaction rate. Next, letter D, lowering the number of the gaseous particles. Oh guys, when you lower the number of gaseous particles, edi reduce mo yung concentration ng reactants, di ba? So if you have fewer number of gaseous particles, that results in fewer collisions kasi konti na lang yung mga molecules or particles na magko-collide. And that results in slower reaction rate. So bakit letter E is true? Heat the container. If you heat the container, guys, meaning ini-increase mo ang temperature ng inyong closed container, which increases the kinetic energy of the molecules and also increases their number of collisions. If guys, you have a number of favorable collisions, okay, that is enough in order to overcome the activation energy and enable the reactants to transform into products. Okay, and thereby this results in an increase in the reaction rate. Letter A. Tandaan na guys, if you increase the temperature, increase ang reaction rate. Next, number 67, for effective collisions to occur, which of the following must be satisfied? Ayan. Okay, ano kayang tama dyan? Okay, so let's see guys kung ang tamang sagot. For letter A, we know that it's true, diba? This is one of the criteria based on the collision theory, diba? In order for effective collisions to occur, there must be enough activation energy. Or recall guys, diba? Based on collision theory, these are the 2 key conditions that must be met. First, sufficient activation energy. The colliding particles must have enough kinetic energy para ma-overcome ang activation energy barrier. So once this activation energy barrier is overcome, okay, the reactants will now transform into products. Okay, so guys, without the sufficient activation energy, okay, no bond breaking or bond forming forms or bond forming occurs. Therefore, there is no reaction in that case. Next, guys, for a chemical reaction to occur via effective collisions, then the collisions must occur in proper orientations. Okay? Bakit? Because the particles must collide in specific geometry in order for a successful reaction to occur. So, tingnan sa letter B and C and D, they are all false. For letter B, guys, it is false because collisions with the container walls do not speed up the reaction. Or recall, guys, diba? Pag, for example, your gas molecules collides with the container, it creates gas pressure, diba? Iba yun sa ating effective collisions on collision theory. Next, for letter C, okay? Well, temperature, we know that it affects reaction rate, tama? Pero, of course, guys, it is not a requirement for effective collisions to occur, diba? Letter D, guys, false then. Okay? Increasing concentration increases the frequency of collisions, the number of collisions, but it does not guarantee to us that those collisions are effective. Again, effective collisions depend on, number 1, activation energy, and number 2, orientation of collision. So the answer for number 67 is letter A. Next, guys, number 68. Ayan. Which of the following is or true about the graphs of the consumption of reactant R as product P is produced? So we are given here statement 1. The reaction is first order with respect to R. Statement 2. 2 moles of P are formed for every mole of R consumed. Okay. Tingnan natin, guys, see statement 1. So, guys, in order for us to see if the reaction is first order with respect to R, okay, ipa-plot natin yung visible points and check natin if first order. Guys, paano natin check kung first order? Through our calculator, through the R squared. If the R squared is equal to 1, therefore, first order ang ating reaction, okay? So again, guys, recall, T is equal to X, diba? Yan yung X values nyo, okay? That's why ang L and R. Try nyo lang i-plot, guys, diba? Tapos get and see if R squared is equal to 1. If it is equal to 1, therefore, first order ang reaction. Next, guys, sabi, 2 moles of P are formed for every mole of R consumed. Tama ba yun? Oh guys, at T is equal to 40 seconds, ito yun, di ba? T is equal to 40 seconds. What is the concentration of the reactant? The concentration of the reactant is 0.02 molar. Tapos the concentration of your product is 0.03 molar. Okay. So guys, imagine nyo, yan yung concentration ng reactant, tama? At that specific time frame. Tapos kay product naman, ito ang ating concentration. So, actually guys, malalaman natin kung ilan ang reactant na nag-react after 40 seconds. Okay, ma'am, paano? O, get the initial concentration of your reactant at time t is equal to 0. Diba? Ito yung initial concentration ng reactant nyo. That is 0.08. Diba? Tapos, again, to get the concentration of the reactant that has reacted in order to form the products, 0.08, the initial reactant concentration, minus the concentration of R at time is equal to 40. That is 0.02. Solving, we get 0.06 molar. So guys, ito yung amount of reactant na nag-react. Klaro? So since ito yung amount na nag-react, ito yung nag-form ng products guys. So compare natin sa nakuha natin concentration for your products. So the ratio of your products. Okay? Again guys, bakit natin kinuha sa 0.06 molar? Kasi ito yung concentration of R consumed. Again, that is the concentration of R consumed. Okay? So again, 0.06 molar is consumed. So compare natin ang concentration of P, which is formed, sa concentration of R consumed. Okay? So again, let's get the ratio. P, R. Okay, wait lang guys. E, R. So ano yung product na concentration guys? It is 0.03 molar, diba? At T is equal to 40 seconds. Now the reactant concentration that is consumed at time is equal to 40 is 0.06 molar. Get the ratio guys, that is 1:2. O sabi sa statement 2, 2 moles of P are formed for every 1 mole of R consumed. 2:1 daw. Eh ano yung nakuha natin dito? 1:2. Therefore, statement 2 is wrong. So the answer for number 68 is letter A. Yes guys? Okay. So again, in order to know how can we plot this on the calculator, again, dapat memorize na by now ang integrated rate loss. Guys, lagi ko itong tinitip sa students, guys. Kapag FECAM formulas, guys, unahin nyo nang i-memorize yan. Okay, unahin nyo na. Okay? Dapat by now, nag-memorize na kayo. Para later on, kapag malapit na yung board exam, kapag malapit na, problemahin nyo na lang ay reviewing those formulas and practicing how to answer FECAM type of questions. Okay? Again, guys, dapat by now, memorize nyo na most of the formulas. Okay? Okay. Now, number 69 naman tayo. Below is a proposed mechanism of the oxidation of sulfite. Okay. So we have here a fast reaction, tapos slow, tapos fast. Which rate law best describes the mechanism? Guys, the first step is fast, the second step is slow. So ang pwede natin gamitin na method ay free equilibrium method. Okay, so let's try to derive. So first, ang unang gagawin ay write the rate law from the slowest step. Okay, so the rate law, rate is equal to K2 times SO3 to the power of 2 minus I2. Ma'am, bakit? Again, recall, we are consuming here SO3 and I2 to form ISO3 minus and I minus. Oh guys, meron ba tayong intermediate? Actually guys, may intermediate tayo, and that is I2. Also fast step, guys, diba I2 is formed, tapos sa slow step, I2 is then consumed. Okay, so I2 is an intermediate, so in the rate law, it must be replaced. So we use pre-equilibrium method to assume equilibrium in the fast step. So guys, in equilibrium, KEQ is equal to products divided by reactants. I2 times I minus over I3 minus. Okay, so let's get an expression for I2. Your intermediate I2 is equal to KEQ times IT minus over I minus. Okay? So substitute natin yan sa ating rate law dito sa step 1. So rate is equal to K2 ito, times KEQ times I3 over I minus times SO3 2 minus. Ito yun, diba? So guys, ano kayang sagot dyan? Letter C. Diba? Parehas lang sila. Okay? Next, number 17. Based on data above, what is the value of the activation energy? Okay, so we have to use the Arrhenius equation solving for this one. Okay guys, how do we solve this one? First, you convert degrees Celsius to Kelvin. So magpa-plus 270 ka dyan, diba? And then, get the x values. Your x values is 1 over temperature, diba? Tapos get the y values. LNK. LN 2.91 times 10 to the negative 6, diba? And so on and so forth. Tapos guys, from the slope, again, in your calculators, this is the linear form, diba? Y is equal to A plus BX, where capital B is the slope, diba? Or M in other words, right? So this is your slope, negative EA over R. Now guys, if you have a value for your slope, okay, to get EA, okay, for example, ito yung slope value nyo, si capital B, just multiply it by negative R to get EA value. Okay, so the EA value, guys, must be in terms of kilojoules per mole. So convert the joules per mole to kilojoules per mole, okay, divided by 1,000. So EA is equal to 1870540 over mole. Convert to kilojoules, we get 187 kilojoules per mole, letter D. Okay, next, number 71. Ayan, very familiar, diba? So nadaanan natin sa PT din. It takes about 3.2 minutes to cook a hard-boiled egg in southern Luzon, but the higher altitude of northern Luzon, where water boils at 9 degrees Celsius, 15 times 4.8 minutes. Estimate activation energy for the coagulation of egg albumin protein. So guys, again, to solve this one, you use the 2-point form of your Arrhenius equation. Again, this is the correct 2-point form. Ln K2 over K1 is equal to negative EA over R times 1 over T2 minus 1 over T1. So guys, we're given here time. So again, guys, inversely proportional ang time and ang rate constant. So we write your equation as Ln T1 over T2 is equal to negative EA over R times 1 over T2 minus 1 over T1. So guys, to get EA, isolate natin si EA, right? So guys, your T1 is the time in southern Luzon, tama? 3.2. This is in southern Luzon. Tapos yung T2 nyo is the time in northern Luzon, C 4.8. Oh guys, ano kaya ang ating temperature T2? It is, can you guess? Syempre guys, yung 92 degrees Celsius, yung nasa northern Luzon. Tapos guys, yung sa southern Luzon naman ay 100 degrees Celsius. Ma'am, bakit? Okay, so this is the normal boiling point of water, di ba? Okay? So parang kunwari guys, southern Luzon, parang normal na height, di ba? Normal altitude ka, nasa base ka. Pero pag northern Luzon, nasa higher altitude ka. Gets ba? Kaya sa northern Luzon guys, higher ang boiling point, di ba? 92 compared to 100 degrees Celsius. Pero syempre guys, di ba? Theoretical lang to. Example lang yan, hindi to totoong buhay, di ba? Okay. So 1 over T2, 365 Kelvin minus 1 over T1, 373 Kelvin times R. Solving, we get, okay, 57.3 kilojoules per mole, letter A. Ayan, so we're done with our chemical kinetics. We're down to our last topic, special topic. So in here, we have 9 questions, guys. Number 72. What is silica gel most likely to absorb to? Okay, so guys, so basically guys, yung adsorbent nyo ay ang silical gel. Tapos ang adsorbate mo, yung particles na mag-adsorb on the silical gel is your oxygen, nitrogen, carbon dioxide, or water vapor. So guys, answer dito is water vapor, letter D. Ma'am, bakit? So guys, silica gel, it is a highly porous form of silicon dioxide. So guys, silica gel, which is a porous form of silicon dioxide, it has a strong affinity for polar molecules, lalo na for water. Okay? That's why it is able to absorb moisture from the air. That's why letter D is the correct answer. Okay? So guys, bakit mali si oxygen, nitrogen, carbon dioxide? They are all non-polar or weakly polar, di ba? So they cannot be adsorbed as effectively ng inyong silica gel. Again guys, kung nahihirapan kayo, nasagutan to, tingnan nyo lang ang odd one out. O sino odd one out? Syempre si water vapor, di ba? Because it is the only one that is polar. Okay? So fun fact, silica gel is used as a desiccant, di ba? Di ba nilalagay siya, for example, sa chips, di ba? Okay? So it absorbs water, di ba? It promotes drying para hindi mag-thrive ang water, for example, sa junk food, sa loob ng junk food, di ba? Ano nangyari guys if may water ka inside the container, inside the junk food? Well, syempre, magkakaroon ka ng modes, di ba? That's why very important ang silica gel. So other desiccants include calcium chloride and activated charcoal. Next, number 73. Which of the following can enhance the rate of adsorption? A, increasing the temperature. B, pulverizing the adsorbent. C, both A and B, or D, neither A nor B. Oh, guys, A and B lang po pipilian. A is obviously false. Guys, we know that the rate of disorption, which usually occurs, okay, decreases, okay, as we increase the temperature. Imagine you guys, if you increase the temperature, diba, you're increasing the kinetic energy of the molecule. So if you increase mo yung kinetic energy ng mga molecules, guys, edi, paano na, mahihirapan sila mag-stick onto the surface, okay? Or recall, guys, in the disorption, you only have weak van der Waals interactions, right? So if you have a higher temperature, therefore, your molecules would rather move freely rather than sticking or rather be adsorbed on the surface, okay? How about letter B? Pulverizing the adsorbent, guys, that results in the increase in the surface area of your adsorbent. Okay? And that increases the rate of the adsorption. Bakit? Because if you increase the surface area of the adsorbent, there is more surface sites available for the adsorbate to adhere to. So marami pang surface sites kung saan didikit or ma-adsorb ang ating adsorbate molecules. Okay? Therefore, for number 73, the answer is letter B. Yan, number 74, very familiar ba? Number 74, surface is half covered by a gas when the pressure is 1 bar. What will be the fraction covered when the gas has a pressure of 0.1 bar? Guys, recall, okay, we will use our equation for the Langmuir isotherm. Okay? Again, Langmuir isotherm. Bakit hindi Freundlich? Kasi wala namang given n, di ba? Diba? Recall, sa Freundlich, kailangan natin ng 1 over n. Wala naman tayong given, guys. So, gagamitin natin si Langmuir equations. First, guys, this is your equation for the fraction of surface covered. That is equal to Q, the absorption capacity, divided by Q max, maximum absorption capacity. Next, this is the Langmuir equation. Q is equal to Q max KLP over 1 plus KLP. Again, interchangeable si pressure and si concentration. In this case, guys, your adsorbate is gas. So, we can determine the adsorption capacity using the gas's pressure. Okay. Guys, tingnan nyo ang equation ng mabuti. Q over Q max is just equal to theta, tama? So, let's rearrange our equation for the Langmuir equation. Theta, the fraction of the surface covered, is equal to Q over Q max, which is just equal to KLP over 1 plus KLP. Now guys, given tayo ng pressure, right? Which is 1 bar. Tapos given tayo ng theta. Sabi dito, surface is half covered at this certain pressure here, 1 bar. So substitute lang natin. 0.5 to theta, because your surface is half covered, is equal to KL times 1 bar, divided by 1 plus KL times 1 bar. KL ang hahanapin natin guys, the Langmuir constant, which is unique to the binding affinity of the adsorbate to the adsorbent. So depende rin siya guys sa type of adsorbent and adsorbate na meron ka. So KL is just equal to 1. Now we can find theta when P is equal to 0.1 bar. So theta, fraction of surface covered, is equal to 1 times 0.1 divided by 1 plus 1 times 0.1. Solving, we get 0.09, letter A. Okay? Next, number 75. Oswald process is the process for synthesizing nitric acid where ammonia and oxygen react using nickel as catalyst. Which type of catalyst is this process? Ano kaya guys? Okay. So in this case guys, okay, ammonia here is a gas. Oxygen is also a gas. Now, your palladium here, okay, your platinum catalyst here, or let's say nickel catalyst. So for example, nickel catalyst yan, okay, your nickel catalyst is a solid. So you have here heterogeneous catalysis, letter B. Again guys, ayusin ko na pagsulat, sorry. Okay, your catalyst is nickel, which is a solid. So imagine you guys, yung NH3 nyo and yung O2 nyo, magre-react sila on the nickel surface. Okay? Again, this involves heterogeneous catalysis because you have different phases. Okay? You have different phases between your reactants and catalyst. Iba ang phase ng catalyst sa phase ng reactants nyo. Next, number 76, which of the following is true of a colloid? Okay, so similar board exam question. Okay, so the answer guys is, of course, letter B. Dispersed particles demonstrate the Tyndall effect. Okay, pag sinabi natin Tyndall effect, nangyayari na to sa colloids, diba? Here, the light is scattered by the colloidal particles. Okay? Bakit C is false? Guys, the colloidal particles, they are too large to pass through biological membranes, okay, or semi-permeable membranes. Lastly, letter D is false. Dispersed particles are less than 1 nanometer in diameter, okay? So guys, we know that colloidal particles are typically in the range of 1 nanometer to 1,000 nanometer, okay? So guys, yung mga particles na may less than 1 nanometer in diameter are particles in your solutions. Next, number 77 also, number 77, the volume ratio of a colloidal to a solute particle is closest to? Guys, ano kayang gagawin? Okay, ano kaya ang ating diameter for your solution? Tanda pa ba? That is 1 nanometer maximum, tama? Particle size for a solution is 1 nanometer maximum. What about the maximum particle size for colloid? That is 1,000 nanometer. Now guys, to get the volume ratio, we can just get the ratio of the particle sizes, okay? So, 1,000 divided by 1 is equal to 1,000, tama? Therefore, the answer is letter B, 1,000. Again, 1,000. Wait lang guys, ginagalo ko lang yung aking drone pad. Okay. Okay. Going back, okay? So, all you have to do guys, 1,000 nanometers divided by 1 nanometer is equal to 1,000. Okay? Again, use the maximum particle size. Recall, diba? Ito yung difference ng solution sa colloid and difference ng colloid sa suspension. Okay? Again, ang basis natin sa problem ay ang maximum particle size ng inyong solution and colloid. Okay? I hope that's clear, guys. Next, number 78. Ayan. How much dry gelatin is needed to prevent the coagulation of 10 ml of standard gold soil? So guys, what is the answer? It is just simply letter A, 0.01 milligrams. Again, guys, gold number, diretso na yan. Gold number is the milligrams of the lyophilic soil na i-add mo sa 10 ml gold soil in order to prevent coagulation of gold nanoparticles when 1 ml of 10% Na solution is added. Okay? I hope it's clear, guys. Yan. Again, diretso na yan. Again, pag gold number, that is the milligrams of the lyophilic soil that you will add. Recall, guys, gelatin, gum arabic, sodium oleate, potato starch are all lyophilic salts. Okay? Next, number 79. This process promotes a molecule from the S0 to one of the vibrational levels of the singlet excited states, S1, S2, and so on and so forth. So the answer here is letter A. Okay? Tingnan natin, guys. For letter A, okay, yung process of absorption of a photon. Okay? So guys, imagine you have a molecule when it absorbs a photon, okay? From ground state, guys, diba? Yung molecule, pinopromote niya siya papunta sa excited state. S1, S2, and so on and so forth. Okay, again, from ground state to excited state. That's why letter A, automatic ang sagot. Meanwhile, bakit mali si letter B? Fluorescence, guys, okay, involves the emission of a photon as the molecule relaxes from the excited state and to S0. Next, emission of a photon is also false. Okay? O bakit? Guys, emission of a photon, very general lang yan. Bakit? It only refers to the release or emission of light. And you have here no excitation, di ba? Baliktad pa nga, di ba? So, vibrational relaxation is also false, guys. Bakit? Because the relaxation only occurs after excitation. Okay? So, in vibrational relaxation, guys, yung molecule nyo, mag-lose siya ng vibrational energy without emitting any light. Okay? So, ang nangyayari sa vibrational relaxation ay, okay, sa excited state ka, for example, nasa S2 ka. Okay? You will only move to the lower vibrational level of the excited state. So, from S2 to S1. Okay? Again, that is what we call vibrational relaxation. So, the answer for number 79 is letter A. Ayan, last. Number 80, which of the following does not occur in an interface? Okay, so an interface refers to the boundary between two different phases. For example, yung mga equilibrium lines sa inyong phase diagrams, diba? For example, this is solid, this is liquid, okay? This is what we call the interface. Okay, so guys, ano kayang sagot? Letter A. Oh guys, hindi pwede magkaroon ng homogeneous catalysis at the interface. Bakit? O pag sinabi natin homogeneous catalysis, it involves the catalyst and reactants in the same phase. Diba? So parang, for example, yung catalyst and reactant nyo, both gas or both liquid. So dapat, guys, in homogeneous catalysis, no interface is involved. Bakit? In interfaces, again, you have two existing phases or different existing phases. Okay? So bakit mali si letter B? Oh guys, B, okay, it can occur in an interface, diba? For heterogeneous catalysis, you can have different phases for your reactants and your catalysts, diba? So it can occur in an interface. Next, crystallization. Okay, so a crystallization occurs at the interface between the crystal surface and the surrounding solution or vapor. Diba, guys? Next, corrosion is also occurring in interface. Okay, so usually, guys, nangyayaring corrosion in the interface between the metal and the air. Gets? Again, yung corrosion nangyayari in between the metal and the air, diba? Okay, so guys, kung nakita nyo na si homogeneous, yun yung sagot, diba? So these are the answers for physical chemistry evaluation exam. Guys, I hope marami kayo natutunan for this discussion. If may questions mo kayo, okay, I will try my best to answer all of them as soon as possible, okay? So guys, huwag mahiyang magtanong please, guys, for any clarifications if may need pa kayong help, okay? And so this is the answer from 1 to 20, 21 to 40, 41 to 60, 61 to 80, okay? And so thank you again, guys, and I hope to see you soon. Bye, guys.